Hello everybody, welcome back. Today we're looking at 6.5 optimization problems. The second part, we're going to explore the solutions in there. So we know there's a region of solutions from the overlapping area. So now what we're going to do is we're going to explore those solutions to see what provides us with maximum and minimum results. Alright, so example 1 says a toy company manufactures two types of toy vehicles, racing cars and sport utility vehicles, SUVs. Because the supply of the material is limited, no more than 40 race cars and 60 sport utilities can be made each day. So there's your first set of inequalities. And however, the company can make 70 more vehicles in each day total. So that tells you how many they can make total. And then the third bullet is our objective function and what's the cost going to be. So it costs $8 to make a race car and 12 to make sport utility. So let's answer these step by step. So it states the variables. So we'll use X. Again, it doesn't matter the order. All right. So I'm going to call let X equal the sport utility vehicles. Again, I'm just mixing this up this time. This time I'm putting this first one as Y, and second one actually showing that it doesn't make a difference. And in short, SUV, right? Okay. So if I say SUV instead of saying sport utility vehicle, it's just short. Okay. And then we'll let Y equal the number of racing cars. And we just call them RC. Okay, just for short. Alright. Any restraint on the domain and range? Well, in this case, obviously, X has to be an element of whole numbers. You cannot have decimal vehicles, but you could have 0. And Y is also an element of whole numbers, right? Okay. So the sport utility and the race cars have to all be obviously 0 or greater. Okay. So what are some of the constraints? So it told us that the race cars are 40 and the sport utilities no more than 60, right? So it can be 60. So it's going to be X. And that would have to be less than or equal to 60. And Y has to be less than or equal to, what did it say, 40, right? No more than 40 race cars, 40. Oh. Okay. The third constraint is, however, the company can make 70 more vehicles in each day, so they can make at least 70 vehicles. So that's going to be X plus Y is greater than or equal to, because it's at least 70, right? And that can be greater than or equal to 70. All right. So I'm going to rearrange that one. I'll bring that one up here actually so I can rearrange it. Doesn't matter where you put them. So I'll bring that one up here. And we can rearrange this for Y. Y has to be greater than or equal to negative X plus 70. Right? So remember, if it's negative, that means the slope is going to be down one, right one, down one, right one, or you just look at this, both the X and Y intercepts are going to be 70, right? So anytime you have X plus Y and then an inequality to a number, that means the X and Y intercepts are the same, right? Okay. The objective function, that's given by the revenue, so, the cost in this case. So cost, we'll use the variable C. All right, so cost is equal to, and the cost of the race cars are 8, and the sport utilities are 12. So it's 8x plus 12y. Okay? The objective function. And then you can graph. Alright? Graph the inequalities. Now remember, again, I'm giving you a graph that has no negatives, so please be mindful of that. It's 60 and 40 and 70, so I'm going to go up by 10, so I'm going to go 10, 20, you know what I mean? It'll make our graph nice and easy here for us. We'll have a graph for 0, 0, I'm going to go up by 10s. Right, so there we are. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and that'll be more than enough. Okay? Give us lots of space on our graph. All right, so our first inequality, if we look back, x less than or equal to 60, we have x less than or equal to 60. Again, we don't want to go to the negatives here, so I'll get rid of those. All right. And then the positive, we have y less than or equal to 40. Less than or equal to 40. A little dark, I'll make that red instead. Okay. And remember that these are whole numbers, so we're going to shade them using our points, okay? So I got rid of the shade. Now again, you can lightly shade if that helps, like I showed before, but we're really interested in the coordinates, okay? And then our last graph is x plus y equals 70, or less, or greater than or equal to 70. For the purpose of graphing, that's going to look like that. So the overlap is within this region here, so we're only interested in the points within here, okay? So I'm going to plot a few of those. I don't need to plot them all. I'm going to plot a few of those. Remember, just plot them on the vertice, and that's more than okay. All right, so that's what I would recommend. All right, so what I mean by that is that we have a point here, and a point here, right? And all of our values are enclosed in here. So we'll start adding some coordinates to there. And that would be 30 and 40. You'll see the dot come up, and we'll make those in black. Okay. And then we have one at 40 and 40. And then we will have one at 50 and 40. And then we have one at 60 and 40. Okay? And then we have one at 40 and 30. 40 and 30. And we're going to have 50 and 30. And we're one at 60 and 30. Okay? And then we have one at 50 and 40. I have that one already, sorry. 50 and 20. 60 and 20. And 50 and 20. And we have our last one here at 60 and 10. $60 and 10. And there's our coordinates. Now remember, there's lots in between here, but you just need to put them at vertices, and that'll be more than fine. So that's a perfect graph for what we need. All right, that's a perfect graph for what we need. So I'm going to take what we need here. And replace that with our graph. And we're going to analyze some of that data. Going to analyze some of the data here. Okay. And just a reminder, you want to label your axis. So the x-axis was the number of sport utility vehicles, right? And the y-axis was the number of race cars, or racing cars. Okay? And those are all feasible, possible areas for your graph. Okay? So again, these are just some possible coordinates, and they're all going by tens. All right. So I picked the three corners too. So this one here is 30 and 40. This one here is 60 and 40, and this one is 60 and 10. All right, and they all satisfy the inequalities. So what we're going to do is, in the next video, we're going to go down here, we're going to answer some of these questions on the next page, on page 14, based on these coordinates that we graphed. All right, so thanks for everybody watching. We'll talk again soon.